Thank you. Thank you so much. Okay, well, good morning, everybody. We have Dr. Joseph Kursky here joining us today. He's from Esri. He's the education manager at Esri in Broomfield, Colorado. And he's also a professor of geography and GIS at Elmhurst College and University of Denver. And he's written a ton of books, textbooks, and publications on spatial thinking and GIS. So he's been very kind enough to offer to give us a presentation today. So I'll just turn it over to you, Joseph.
Thanks, Dr. Shalaby, and greetings, everyone. Good to have you aboard here. We're going to have a geospatial time. Get it, a geospatial time in the 4 hours that we have together. Just kidding, we don't have 4 hours together, but your professor has asked me to give you a bit of an introduction to what geospatial technologies are, geographic information systems and related technologies, remote sensing, GPS, global navigation satellite systems, web mapping, and why you should care about it in your engineering program or your hydrology program there at Howard University. So I really want this to be useful for you all. So if you've got questions or comments or things you want to learn more about, feel free to put those in the chat, and your professor will either wave at me or interrupt, and that's fine. I want to make this really useful for you all, okay? I've got my colleague Clinton Johnson on here with me. We're both at Esri, and what is Esri? We'll talk about that in a minute, but this is just a couple questions I want you to think about right at the beginning here. What do you want to see in society as we go, navigating our way toward 2030? What do we want to build? What do we want to see happen in people's lives and in our communities and in our country and our world? And also, how can you, students that you are, and you've chosen a really wonderful university, you've got some really fine professors that I've met over the last few weeks, you've got some great colleagues here in class, how can you chart your own pathway forward so that you can achieve your own personal goals, your professional goals, and then also advance these societal goals? Those may seem like kind of big questions for, a morning session like this, but I just want you to think about how geotechnologies, and we'll talk about what they are, can help fit into those personal goals of yours, and then also what we want to see in society. A couple of things that I wanted to lay out before you, just something to chew on, is that education is still going to be around. And these are disruptive times, and I just admire you students and you professors out there that are, doing your utmost to navigate these strange waters that we're in right now. But education is going to remain, and geotechnologies, web mapping, etc., are going to be relevant, and they're going to continue to evolve. And the reason why is because everyone is asking the where question. We'll talk about that, but every single sector of society, whether it's human health, public safety, transportation, social work, hydrology, engineering, everybody is asking the where question, not just a where question, but the whys of where question. I like to think about geotechnologies in this way. What's where? Why is it there? And why should we care? What's where? Why is it there? And why should we care? That, to me, is the essence of what we're talking about today. And don't worry, this geotechnology stuff that I'm talking about, it's a lifelong endeavor, just like engineering and hydrology. You're not going to learn it all in, the 60 minutes that we have or the 45 minutes that we have together today. But I'm hoping that this little bite-sized, gluten-free nugget, if you will, of geospatial technology will get you excited about, hey, that sounds pretty cool. I actually might be able to use that in my career or in my university coursework and then beyond. So here's another thing I want you to think about. I invite you students, I didn't really think about this so much as an undergraduate, even as a graduate student, but I encourage you to start now with building your professional network. You've got some great mentors and professors. They could be lifelong colleagues. I didn't really think about this while I was a student. These professors that I had, we could actually collaborate even after I graduated. And we have. We've written articles together and things like that. So I invite you to think about your professors and get them in your professional network, LinkedIn, et cetera. There's lots of ways to connect nowadays. Also find someone like Clinton Johnson, my colleague, and I at Esri. Private company, get someone in a private company, get a bunch of people, and then get someone or more people in a local government, in your state government, in your DC government, in a national organization, et cetera. Get someone in a government agency. Also get someone or some people in a nonprofit. Anyway, so you get nonprofit, government, private industry, and academia in your professional network. And that's going to help you in your future. I've learned a lot from my colleagues and mentors. I mean, we're lifelong learners, which is another thing I wanted you to think about today. Now, I don't want to bore you to tears with my own background, but just to kind of get you thinking about, hey, where could I end up working with these geotechnologies and with engineering and hydrology on my tool belt? Where could I actually end up working? In my case, it is largely in federal agencies. So I started out at NOAA, the National Oceanic and Atmospheric Administration. So I love, water and hydro. So it's when Dr. Shalaby said, hey, these are my hydro students, I'm like, oh, I'm all over that. I love this stuff. So NOAA, and then I worked at the U.S. Census Bureau, actually right outside of DC there in Suitland. So I worked in Suitland and also in Denver at the U.S. Census Bureau as a geographer. And then at the U.S. Geological Survey, in, again, creating spatial data and the stuff that we're going to talk about today. And now I'm at Environmental Systems Research Institute, or ESRI, on their education team. Now, the education team is to support students, faculty, deans, provosts, everyone, teachers, students at the high school and middle school level, et cetera, all to help them use geotechnologies, geographic information systems, remote sensing, and other things that we chatted about earlier. I also, like your professor said, love teaching and love interacting with students. So I'm teaching at several different universities and love nonprofit organizations. So National Council for Geographic Education and some others. So anyway, just think about the neat thing about this, just sharing this, again, not to bore you to tears with my own pathway, but think about, as you move forward, you don't have to just stay in one position. You can move around, as I have. And I've been really kind of blessed to be in 4 different sectors of society. Now, we're all about space and place. So here's just 2 things to share. Think about where you grew up or where you are right now. I know all of you are remote right now. So think about, we're very much tied to space and place. It's very much a part of our human experience, right, folks? So think about the neighborhood where you grew up, for example. You could probably make a mental map, and you could probably even draw it on paper or in a digital geographic information system that we'll talk about in a minute. But you could probably make that map in really fine detail, right? How you walked to your friend's house, how you got to school, the vacant lot behind your school, all that kind of stuff. It really great detail. I mean, I can describe that, and I go way back to the 20th century with my own childhood, way back in the late Jurassic, the Cretaceous period, not long after the dinosaurs were roaming around DC. Anyway, but I could still describe that in really fine detail. So we're very much a species that's tied to space. It's really fundamental to what we are. And that feeds into what we're talking about today with geographic information systems. Maps have long been very powerful tools of communication on clay tablets, wood blocks, metal. Al Idrisi's map from the 1100s on silver, a map on silver. Wow. To film and now into digital form. So this is the photograph that I've chosen for where I am right now, out in Colorado. And I've been to DC numerous times. I told you I used to work in Suitland. And this is sort of, the edge of the short grass prairie and where it turns to the Rocky Mountains. So we're at the edge of 2 major ecoregions and lots of recreational activities. As you can see here, I'm on my bicycle, but people on horseback and, lots of recreational activities. Now, one of the things that I wanted to share with you all, especially you hydro students, I want you to think about, what's your favorite water body? Oh my goodness, that's probably not a question that a lot of people ask you, but I've been saving that just because I knew that you were going to be here. This is on my YouTube channel, which is, it's pretty geeky, okay? It's got thousands of videos on GIS stuff. And this particular place, I was in the Netherlands once on a work trip. You hydro students, you probably have heard of this thing. It is the Maaslandkering. It is this big, huge gate that holds back the North Sea from the port of Rotterdam. So you can see this big this big structure that's on both sides of this estuary, it's open right now, but when the sea gets high in terms of a storm surge, those things close, and it prevents that water from flowing up and flooding not only Rotterdam, but a lot of the surrounding villages around there. So you can see this kind of brought me a great thrill to see this right here. But the point I'm raising here is that A, we're tied to space and place, and B, there's some amazing engineering and waterworks around the world, right? Even right there in DC. This is my favorite one that I just shared with you. But C, and the last point here, is that all of those gates and that flood control, not only for the Netherlands, but for many other places around the world, that's all actually run with the Internet of Things, sensors, and GIS, Geographic Information Systems. It actually controls all of that flood prevention network. It's not like a human being looking at, oh, the sea is getting high, we better close the gates. It's all run with the sensor network. Live feeds coming in from ocean buoys and weather sensors, and also the human element, people capturing data in citizen science mode, which we'll talk about in a minute. But that's pretty amazing. Another thing that I wanted to share is that every single person pretty much with a computer has looked at this over the last 9 months, correct? The JHU coronavirus dashboard. So this is a very serious issue, as you know, of our time. And this is built on this ArcGIS technology that Clinton and I and our organization create. Now, we don't just sit around and say, we need to create these tools. We get input from people saying we need tools that can help us, in this case, visualize what's happening at the global level, what's happening at the US level in terms of the COVID-19. So this is called ArcGIS, and it's a particular web mapping application called a dashboard. And just like the dashboard in your car, it gives you a lot of information in a short amount of space. In this case, it's giving you information about cases, as you know, from looking at this, but also it's from a live feed. So I've talked about the Internet of Things and getting live feeds. Well, let's take a look at one county. This is called a infographic. You've probably seen a lot of other infographics over the last few years. They're very common nowadays, and many of them are tied to maps. And the reason why we get excited about this is because they give you data, again, in a short amount of space, just like the maps from ancient times on wood blocks and clay tablets and things like that. This gives you a lot of information, and it's coming from these live feeds. So you get in this case, Fairfax, Virginia, just across the river from y'all. But this is created with this Geographic Information Systems technology. So it's tied to real-time data, whether it's COVID or wildfire perimeters or the level of the river on the Potomac or the Anacostia or whatever at any particular time. So you've got those stream gauging stations relaying data to these dashboards. And just as an example of how you could actually do this, let's take an issue that you're passionate about. What are you passionate about in your community? In my case, I'm really passionate about walkability. How walkable are communities? So when I'm, in the not too distant past, when I was on work travel, which was about half the year, visiting campuses like yours, and hopefully your professor and I were talking about me actually visiting you all at some point next year. But I'm really passionate about, is this place walkable? So this is a story map. It's a web-based, interactive, multimedia map that you could actually build, and we can talk about how you could actually build one of these. But here's mine on walkability. I've got a little bit of text about walkability and what it is and why communities care about it. And then I have another piece of this Geographic Information Systems platform. We already talked about dashboards. We talked about story maps ever so briefly, which is what this is. But here's another piece of the platform. This is a survey. Now, many of you have probably used Google Forms or SurveyMonkey in the past, where you're dragging and dropping true, false, multiple choice into a survey. And you've probably been barraged in your lifetimes of surveys. I remember in the not too distant past, as soon as I get off the airplane, hey, how was your flight? It was a survey, right, from the airlines. So you're getting lots of surveys, people wanting to know your opinion on things. In this case, I have a survey that I created asking people, hey, is this place walkable or not? Is it pedestrian friendly or unfriendly? Rate the walkability, horrible to excellent. and then tick all the choices that describe the site. Is there a dedicated path? Are there branches? Is there snow? Is there rocks or something? Is there dangerous cross traffic? And then, really important to what you and I are talking about today, where is it? And do you have a photo of it? So in my story map, back on my story map, I actually have a series. This is a seamless interactive map of the world in this GIS platform, this Geographic Information Systems platform that we're talking about. I've got a whole series of points about walkability. Is this place walkable or not? Yep. So the point is, oh, and here's one of my own points that I submitted. Here's me doing my Richard Nixon impersonation in front of the Capitol. Anyway, the point is that's a very walkable place right on the National Mall. Yeah, just for a little fun there. But the point is, this is a live feed coming in from my survey to this web map, right? Every time someone submits, and this is an open survey, so you could actually walk your neighborhood right now and submit some points to my survey. And more importantly, you could create your own survey for something that you're interested in. So inside my same story map, right at the bottom, I have what should look pretty familiar to you right now, and that is a dashboard. So the dashboard, just like the map, and I've got a little copy of the map right here, as you can see. I've got a couple of pie charts, pretty simple dashboard. Right now, about 2/3 of the points that people have submitted are pedestrian friendly, and about 1/3 are pedestrian unfriendly. Then I've got the characteristics in this graph, as you saw from my survey: branches, snow, a wide path for pedestrians, dangerous cross traffic, etc. And at this time, as of this date and time in history, 423 points have been submitted to my walkability survey. So that's my little gauge on my dashboard. But the point is, this dashboard is the same tool as this dashboard, okay? It's the same tool. It's ArcGIS. And that's the software that you have access to at Howard University. Very cool that you could do your own studies with, and we'll talk more about that in a minute. But the point is, you've got this tool available at your fingertips to study a wide variety of different themes and topics: hydrology, engineering, social work, etc. Okay, so that's a little introduction to this. Another introduction to what is a geographic information system is as follows. I'm going to scroll down to this. Geographic Information Systems. It's known by several names: Geographic Information Science, Location Intelligence. You might see Location Analytics, Health Informatics, especially over in the health field, Geomatics, especially up in Canada and some other countries. That's what they call it. But in 2004, the U.S. Department of Labor said, hey, there are 3 hot growing fields for the 21st century: nanotechnologies, biotechnologies, and geotechnologies. And the geotechnologies are what we're talking about today. I like to think of it as 3 components. First of all, there is the tools, and we'll talk about the tools. So for example, you can drop a point on the landscape, and then you can, for example, here, I've got a live interactive web map in ArcGIS Online. I'm going to add the rivers. You hydro people must love this, that you've got the rivers here. And as I zoom in, I see more detailed rivers. And look, I've got a little dotted brown line on the map. The watershed boundaries, pretty cool. I've got that all at my fingertips. So I can really see, for example, the watershed boundary between the Potomac and this one down here, the lower Chesapeake, and then I've got this down here, the Roanoke watershed. Fascinating that I've got this all at my fingertips. So knowing that, and if I zoom out a little bit, I can drop a little point on the map saying, kind of typical thing that you would do in a hydro analysis. I mean, this is a real simple example. We get into more advanced examples, time permitting. But okay, where does the water flow from that point? You know, your classic dumping a cup of water on the ground, and where's it going to flow? Okay, in this case, it's south of the watershed boundaries. You can see here, if only we had a measure tool. Look, we do. Oh, awesome. So I can measure from here to this point that I dropped, and it's about 9.5 miles south of that watershed boundary. Okay, well, because of that, the water's going to flow down Jackson River here into the James River and out to the ocean. So how does it know where to draw that line? It's because underneath this is if this isn't just a bunch of lines, points, and polygons floating around in cyberspace. It's tied to a geographic information system. So there's a database behind here, and one of the databases behind this particular map is the, as you would expect, the elevation. So it knows based on that location, where is the water going to flow? And then it's got another database about the hydro network, about the flow of the different rivers, which we've gotten from NOAA and EPA and the US Geological Survey. So there's a lot of data that goes into this simple, dropping a pin on the landscape. But we've also got real-time data. For example, we could pull up a layer of the gauging stations on that river right now and figure out, what's it like on the Potomac, what's it like on the Anna River, the James River, et cetera. What's the water flow right now? And the reason why is because, as you folks well know, people want the data now. They want it in real time or near real time as possible. So GIS is more and more tied to this sort of Internet of Things, where we're getting live feeds from various sources, including people. As you saw with my walkability survey, that's just ordinary people submitting data about if their community is walkable or not. So just as an example, I pulled up here just with this add button inside this is ArcGIS Online, which is a component that you have at your fingertips here at Howard U. I'm going to search for layers, and what I added was current weather and wind data. So, okay, if I click on a point in it is about a half an hour old or so. So it's not completely real time. It's slightly off of real time, but still close to real time. I've got scattered cloud conditions, and it's a lot warmer where you are than where I am. Right? We've got snow on the ground here in Denver, which is good because we've had a lot of wildfires, and that snow definitely helped the situation. So again, why does this matter? Because we've got a dynamic, changing Earth, and we need to analyze it with a geographic information system. But just to give you an idea of what's going on here, let me turn off some of these hydro points. Now I've got the stations, okay? And let's say I want to change the symbology. So I'm going to change the symbols. Instead of wind speed, let's say I want, how about the air temperature? And it's important to know about the unit. So in this case, it's F instead of C, degrees C. But now I can say, okay, I don't like those symbols. It just doesn't show me what I really want to know. So how about if I go instead of size, let's go under color. How about okay, I kind of like that, but let's go under options. Ooh, classify data. Maps are really powerful, and how you symbolize and how you classify data really affects your end user. And Mark Monmonier, geographer, has a book called How to Lie with Maps. The point of the book is maps are really powerful. You have a powerful set of communication tools at your fingertips. Use them wisely, right? The whole, with great responsibility comes, or great opportunity comes great responsibility. So you're responsible for, if you're creating one of these maps, to really think carefully about how you're going to display the data. Now, let's say I want not natural breaks, but maybe, how about quantile? Same number of observations in every category. Okay, so now I see these colors, and if I like those colors, great. If I don't, that's fine too. So I'm just going to say okay here and then say done. Now I'm going to pop up a legend, and now I've got, okay, a temperature map. And if I scroll out, I've got basically in this data set, I've got global temperatures in here. Some countries have a lot more data points than other countries, certainly. But now you can see just at one glance, and let's go ahead and change the base map. That base map is kind of getting in the way. So let me go with this light gray base map. Now you can see exactly what I was talking about earlier. So out here to the west of you, we got 12 degrees out here in Colorado, and you've got basically 58-ish. So you can see at one glance that there's this wall of cold air that's probably heading your way, and it might be a little cooler there in the next few days. So that is an example of a geographic information system. You've got a map with data, but you also have the I part of GIS, which is in this case weather, or it could be streams, or it could be population of neighborhoods, et cetera, which we'll talk about in a minute. So this is the I part of GIS. It's a database. Think of Excel, but it's a geodatabase, so it can be mapped. So you've got the G part, which is the map. You've got the I part, which is the table, and then the S part brings it together. So if I went to this particular point right here and clicked in the table, and then I went over to these three lines here, and I said center on selection, that selection point is actually offshore, is this one right here that's highlighted in the table. So they're linked. The G part and the I part are linked. Okay. Also, another way of thinking about this is that all of this is fed by data. Now, I know you folks in engineering and hydrology, you love digging into data, right? And that's kind of near and dear to your hearts. And the data really matters, right? Because what you're putting into your maps or your geospatial technology affects your final result. So data quality is important. And I know this sounds super boring, this data blog that I'm going to talk about in a minute, but it is called the Spatial Reserves Data Blog. Now, I wrote a book on this topic called the GIS Guide to Public Domain Data, which I know sounds super boring, but it's really important to the discussion that we're having right now, because let me just illustrate as an example. I've got a post on satellite imagery, which is a key component of geospatial technology. And one of my examples in here is this satellite image right here. So the point I'm making in this particular essay, and this is called the Spatial Reserves Data Blog, if you want to search for it, I've got all kinds of discussions about location privacy and other things. You know, and that app on your phone, why does it want to know my location? Do I need to say allow? And if I do say allow, does it matter? So how many of you have like a fitness Fitbit or a fitness app or something like that, and you're recording your bicycle trips and your walks and your runs and stuff like that? Probably several of you do. And so if you share those, theoretically, if I shared mine, you'd be able to find out where I live out here in Colorado. And do I really care if you know that? Okay, just some stuff to think about in terms of sharing your location. You know, advertising agencies, for example, they really want to know your personal habits and mine, right? So they can aggregate that, and so businesses can use that information to figure out, okay, this is a good location for a coffee shop or a skateboard park or something like that. So in this particular example, the point I'm making here is that even satellite images need to be viewed critically. Now, we love all these tools that Geographic Information Systems allow us to take advantage of. And I talked about the trace downstream tool. It's just one of hundreds of tools that you have at your fingertips. But this tool right here is the most important tool for you to develop as students, okay? Your brain, it is the one that you need to nurture, and you need to be a lifelong learner in this. And this is a perfect example. If I were to peer over the aircraft or the satellite that's taking this image, it would not look like this on the ground if I was able to peer over that satellite or aircraft. Why? Because as you can see here, it's never going to look like that on 395 in DC or in 35E in Dallas, Texas. Why? Because there's no moving vehicles. So all the vehicles that are moving have been removed from the image. So the image has been manipulated. It's been run through an algorithm where all of the moving vehicles were removed. Now, it's not necessarily for nefarious, strange purposes. It's because probably the DOT, the Department of Transportation, wanted all the vehicles removed because they wanted to see what the condition of the pavement was. So they could maybe do a resurfacing assessment, which lanes need to be resurfaced. Do we need to plan an HOV lane, a high occupancy vehicle lane? And if so, where should that be? Is there a light rail potential in here? You know, that kind of stuff. But the point is, even satellite images are not necessarily what you would see with your own eyes. Other kinds of satellite images that you have at your fingertips are taken in like infrared. So they're taken in a different part of the electromagnetic spectrum than your eyes can see. And that the reason why is because we want to see things like healthy vegetation, you know, for parks in DC or in the Shenandoahs or wherever. And so we want to do a vegetation assessment. So we look at things in different parts of the spectrum. Anyway, the point is, be critical of data. And again, this tool right here allows you to do that. You keep nurturing that part of the geospatial tool set. Okay, continuing on. Why is GIS not commonly thought about in hydrology and engineering until most recently? And I just salute your professor, Dr. Shalaby, and others there at Howard U. I mean, you students out there, be thankful you've got professors that are looking at accessible, compelling, but also very useful technologies for you to include on your tool belt as you go forward. Traditionally, GIS, or Geographic Information Systems, was largely taught and thought about in universities anyway, in geography departments or in environmental studies programs, or even in city planning. That's traditionally been the home of these technologies. But more and more people, yourselves included, in engineering and other sciences, saying, hey, we're going to be asking the where question also, and we need to know about these tools so we can use them effectively. Also, another reason why they're not commonly thought about is that somebody maybe in the past has taken a geographic information systems course and said, oh, that was really complicated. That was really hard. And yes, that was then and this is now. Just think about other technologies that you've used in the past. They've evolved, right? They've moved forward. And every time GIS evolves, it gets easier to use and more powerful. Easier to use and more powerful, which is wonderful, right? So just this example that I showed earlier, pretty intuitive, right? You've got some analysis tools up here where I use the trace downstream tool, for example, and I said, hey, I'm going to trace downstream. So it's this tool right here. And I said, okay, I want to drop a point on the map. And I dropped my point. And then it said, okay, Joseph, how long do you want the trace to exist in miles or kilometers? And then do you want to clip it to the study area? In other words, to the map extent here. Done. Save it, give it a name, done. So the tools are actually pretty intuitive. It's much easier than in the past where we would say, hey, you students at Howard U, here's a set of manuals, and there's probably a bunch of these. Okay, let's take a bunch of manuals, and you learn GIS, and then we'll talk to you in a few years after you learn this. And oh, by the way, you'll have to set aside your standard career of being a hydrologist or a civil engineer or in other fields, and you become a GIS analyst. That's not the way it is anymore. The way it is now is that you have GIS on your tool belt along with CAD and BIM, building information management, R statistics, Python coding, and maybe some other tools that you have on your tool belt. And this becomes one of those tools. You know what I mean? I wish I could get excited about this. Are you folks okay? Is everybody with me? Hopefully you're not saying, Joseph, this is the most boring presentation ever. I'm being tortured here. Now, hopefully there's some nuggets here that you're okay, they're saying, this actually could be pretty intriguing. Let me give you a couple of demos that would hopefully spark your imagination a bit more.